One summer night, one summer night, one girl stole my heart, stole my heart. One summer night, one summer night. She's so sexy, she's so fine. I can't look anymore, I'm gonna lose my mind. She's so sexy, she's so fine. I can't look anymore, I'm gonna lose my mind. One summer night, one summer night.
The first attempt at a definition says that it is the scientific study of the form, content, organisation and evolution of the universe. But it goes on to say it is the branch of metaphysics dealing with the origin and structure of the universe. And here's where we get into trouble, because metaphysics is in fact a kind of fiction. We can say nothing about the origin of the universe because we don't understand the origin of matter. So we ask the question, is it the queen of sciences because cosmology is supposed to be the all-embracing science? Everything else must fit under its umbrella. And if that's wrong, then we don't have any real picture of our place in the universe or of our status as living creatures. So I ask the question, is it the queen of the sciences or the handmaiden of our culture and politics? And I say this because our modern cosmology of the Big Bang has more in common with the religious belief than anything to do with science. And also the politics involved in the Big Bang and also in academia in general is something not to be suffered, in my opinion. So the next question is it just another creation myth dressed up in virtual reality? And you all know what virtual reality is. It's the kind of thing they use to make films like Avatar. And we're very clever at that. So when you watch programs on astronomy, most of the images there are virtual reality. They've been drawn by artists under the direction of astronomers and other scientists. And it is a creation myth. It is creationism, because it's been called the ultimate free lunch. In the beginning there was nothing which exploded. It explains nothing. This is a friend of mine I met at one of the Plasma Sciences conferences in the US. Dr. Gerrit Verschuur. He's a radio astronomer, and radio astronomers are very important in the electric universe because they're the people who can actually map the electric currents in deep space with their radio telescopes. And he asked in his book, Interstellar Matters, who are we as a species to dare ask such mighty questions as concern the origin of the universe, and in unique arrogance believe we may have the correct answer within cosmic microseconds of the asking. What we have right now I would call horse-and-buggy cosmology, because most of the key ideas were formed in the horse-and-buggy era, or even before. Of course, the first was Newton, and he was definitely in the horse-and-buggy era, with his laws of gravity. He at least had the common sense not to make any suggestions as to how gravity works. He just gave us a mathematical formula that describes what happens. We have Eddington, who gave us the theory of how stars work, in particular the theory of the interior of the sun. And we have Einstein too. I think we can classify him as having at least lived or started his life in the horse-and-buggy era. So our present cosmology is really an accident of history that we haven't recovered from. It's another cosmology, the Big Bang cosmology, in a long line of traditional cosmologies, and they all have certain features in common. The creation stories are sacred, and they must be retold word perfectly. They invoke celestial gods, heroes and magic. We do the same right now. No critical dialogue is allowed. No correspondence will be entered into. And those who deviate from that story will be punished or banished. Nothing has changed. As a result, there is no progress. And that has been the situation for the last 100 years, I would suggest. The Big Bang creation myth is just another miraculous creation myth that abandons science. I don't know if you can read the cartoon here. The little alien is walking back to his colleague in the UFO saying, "You won't believe the cosmology they've come up with." The story needs magic to begin, the magical creation of matter from nothing. And it also needs it at various stages in the narrative. It's what's called, in scientific terms, renormalization. When all of your equations start to head out the window, you have to actually open the window and see what the real world says and plug those in to keep going. In other words, you invoke a miracle. It has its sacrosanct heroes and a god, which of course has to be a mathematician, because the Big Bang theory is based largely on theoretical mathematics, not on physics. It's based on the firm belief that the universe is expanding. We have the evidence, and have had it for decades, that the universe is not expanding, but that evidence is not admitted because we have a very firm belief in place. It denies evidence that can't be woven into the myth, and that's typical of traditional cosmologies. So what we have is another traditional cosmology. We could not say that it's much better than that of the Aborigines. Some people have suggested that it is a new Ptolemaic universe that we have. Yes, you can develop a hypothetical geometrical gravitational model that gives the desired answers, but having to live with 96% of the resulting universe being dark and unobservable is no better than using the geometry of Ptolemaic epicycles to describe celestial motions around a central Earth. When you look at this diagram here, it shows you, under the Big Bang theory, how much of the universe is dark or unobservable. That's the little bit there that's real in the Big Bang theory. If you're happy with that, you'd be happy with anything. The important point to make is that mathematics is very valuable. It describes observed behaviour. However, it explains nothing. Unless you've got the right concepts in place to know what mathematics to apply, then all you're doing is describing behaviour. You're not explaining things. Modern cosmology is full of confused ideas. To begin with, quantum theory and relativity theory, which are both the two main pillars of Big Bang cosmology, are incompatible, and Einstein recognised that problem. Also, occasionally we get these headlines: "We don't understand gravity." Various experiments that are carried out or results that come back from spacecraft suggest that there are problems with Newton's law of gravity. The question is Newton's law of gravity all that's acting out there? E equals mc squared, the best known and least understood equation I think there is in physics. Because in textbooks and in encyclopedias, within a few sentences of explaining this, it says E equals energy, m equals mass, c equals the speed of light. You will see the word matter introduced instead of mass, as if the two are interchangeable. In reality, physicists have no idea why matter manifests with mass. In fact, they're spending billions on that Hadron Collider to try and find a hypothetical particle which causes the phenomenon of mass. It's one of the craziest ideas I've ever seen. Meaningless language is used. Space-time, the fabric of space-time. They hyphenate space and time as if they're the same kind of thing. They're two entirely different concepts. And then to call it a fabric is to introduce more confusion. And the confused use of language. This applies to things like the multiverse. Now, the universe is defined as everything there is. To talk of a multiverse is nonsense, is meaningless. because the universe includes everything, even if there were multiple versions within the universe. Also, to talk of the universe expanding is meaningless. Expanding into what? So there's a lot of confusion in the language. The word dimension is used a lot, and it's misused by many as a result of the mathematicians' use of the word dimension, which often means degrees of freedom. It has nothing to do with space or extra dimensions of space. So the bottom line is mathematics isn't physics, and yet most of our current cosmology is theoretical mathematics. This is Dame Jocelyn Bell Burnell, who is famous for her discovery of the little green men, the pulsars, the signals that were received at the Jodrell Bank radio telescope. In a BBC show earlier this year, this is a direct quote from that show: "I have this sense that we need to picture cosmology, the evolution of the universe, in a whole new way. Our nice simple picture is getting messier and messier and messier. Sometimes you discover the picture you thought you had, everybody thought we had, actually turns out to be wrong." So new concepts are needed, and I'd say that is the bottom line. It is impossible to devise a real cosmology from perfect mathematical principles alone. The physical concepts must be in place first and confirmed by experiment and observation. The principles of physics must be followed. And this is an important point, and one that's often overlooked. Cosmology must be interdisciplinary. In other words, it's a theory that can have no exceptions. It doesn't matter what subject you're talking about, whether it's biology, geology, or the history of man, everything must fit. And that includes crystal skulls and giants in the past. Now, Big Bang theory has nothing to say about life, nothing sensible. It's just an accident according to the Big Bang theory. And it has nothing sensible to say about the origins of planets or the solar system. So in other words, it's not very useful at all. The little cartoon, which may not be readable, this step here says, "Then a miracle occurs." I've seen that done actually in lectures on astrophysics. That's what I said, they call it renormalization. Here's a well-known physicist. Every effect has an antecedent cause. These are just the basic principles. If you depart from this, you're not talking science. No creation from nothing. No annihilation of matter. No time reversal. And the finite cannot become infinite. Those are my principles. If you don't like them, I have others. The Big Bang theory is always associated with Edwin Hubble and the Hubble expansion and the Hubble constant. But what did Edwin Hubble actually say back in the 1930s? If the redshifts, and the redshifts are supposed to be a measure of the expansion of the universe, the more the redshift, the faster the object's moving and the more distant it is. So he said if the redshifts are a Doppler shift, the observations as they stand lead to the anomaly of a closed universe, curiously small and dense, and it may be added suspiciously young. And that was a problem for many years, where some stars appeared to be older than the universe. But he said, on the other hand, if redshifts are not Doppler effects, these anomalies disappear, and the region observed appears as a small, homogeneous, but insignificant portion of a universe extended indefinitely, both in space and time. That was in 1937. He went to his deathbed saying the same thing, and I regard that as the most sensible position for a scientist to take. He had a student called Halton, or he's also called Chip Arp, his boyhood name. He has been termed by those who have looked at the evidence a modern-day Galileo, because he's recognised in astronomy by his Atlas of Peculiar Galaxies, where he examined galaxies that were distorted and compiled this atlas in the process, he discovered that these high redshifted objects were preferentially situated near these distorted galaxies, as if something had gone on to create these highly redshifted objects. So he went on to show that Hubble's preferred option was actually the correct one. But that, of course, meant that there was no Big Bang. So what happened? He had his papers rejected and his telescope time taken away, and he was one of the most promising young astronomers at the time. On the left, this was his paper, scribbled in the corner by Subramanian Chandrasekhar, the editor of the Astrophysics Journal at the time, was, "This exceeds my imagination." Now that's no kind of a comment for a scientist to make on a paper. What he meant, I think, was that he couldn't imagine what would happen to him if this paper was published. Because what that paper was showing was that here's a normal galaxy here, which has a bridge of matter between it and a little companion galaxy. But along this bridge are some objects, one here, and these are very highly redshifted. This is the most highly redshifted, that's the least highly redshifted, followed by the companion galaxy. In other words, all of these are related. So if this high redshifted object is related, it cannot be near the end of the universe, which means that the redshift relationship refers to the youth of an object, not to its distance and its faintness as a result of its youthfulness. I mean, this is a pretty simple idea. Fred Hoyle wrote, as a result of this paper, there was no Big Bang. The galaxy is the bridge to future physics. In other words, he was referring there in a sort of double meaning. That bridge of matter meant that there was something we don't know, fundamental to the nature of matter. Very important. Halton went on to show that quasars, these highly redshifted objects, are actually born from the nuclei of active galaxies. That's galaxies, something very strange is going on right in the centre, normally attributed to black holes. A follow-up paper came a while later, The Big Bang is Dead. What they found was that right in front of this galaxy there was a jet and a quasar on the end. So in other words, this quasar could not be behind this opaque nearby galaxy. Halton was right. The result has been stonewalling. Even NASA now publishes pictures which are cropped or shown in such a way that you don't see the bridges, or they're discounted in some fashion. One of the other important things that Halton found was that these redshifts are quantized. Now this is absolutely astounding, because it's generally believed that quantum effects only occur at the subatomic level, and here we've got galactic-sized objects exhibiting quantum effects. This flies right in the face of Einstein's idea that the speed of light is some kind of a speed limit. Halton work has been published in a couple of books, but this one is probably the most significant, Seeing Red. And that has a double meaning, of course, because his treatment at the hands of the astronomical fraternity is absolutely disgraceful. In that book he presents all of the evidence in favour of his ideas. Strangely enough too, a lot of his ideas do coincide with the electric universe model that I'd come up with before coming across Halton. We've had clues about the electrical nature of the universe way back in the 1800s, and in fact it was not a taboo subject then. Here we have Sir John Herschel, who wrote in 1852 to Faraday, "We stand on the verge of a vast cosmical discovery such as nothing hitherto imagined can compare with." Now these words are the same ones that have been used to me by scientists who've come over to my side, seen the light, so to speak, and seen the enormity of the change that this will introduce to science and our view of ourselves. This was in a letter to Faraday about the link between magnetic storms on the Earth and sunspots. This is Halton embracing one of those plasma balls. You've all seen them. Halton I think, is very keen on the plasma cosmology. Plasma cosmology forms a part of the electric universe, as I'll show. The important point is that 99.999% of the universe is plasma. None of this, 6% or so as real matter. This is almost the entire visible universe. What is plasma? I'll answer that in a moment. And what is plasma cosmology? Because I have to distinguish that from the electric universe model. And what is an electric universe? Plasma has been called the fundamental state of matter. It's also been called the fourth state of matter because it was the last one discovered. All of the matter on Earth is not in the plasma state. It's solids, liquids and gases. Plasma is another state where the atoms are dissociated so that some of the electrons are free to move and you leave behind positively charged nuclei so that you have positive and negative charges moving around. That means that they're subjected to the electric force, if there is one, or a magnetic force, and they behave in ways quite different to a gas or a solid or a liquid. So plasma is electrically conductive. In fact, it can be more conductive than copper. And it responds to a magnetic field. Moving plasma generates electric currents in nearby plasma, and it forms various discrete forms that are recognisable. For instance, the solar wind forms a sheet in the solar system where the planets are orbiting. It forms filaments, like you see over here, and it can form bubbles like the magnetosphere of the Earth. The magnetosphere is wrongly called. It should be a plasma sheath. It's not. It's there because the magnetic field is there, of course, but there are also electrical requirements to form a magnetosphere. The other thing is that it produces radiation over large parts of the electromagnetic spectrum, and this is why the radio astronomers are important, because they can detect that radiation. The behaviour of plasma as a result of its response to electrical and magnetic forces is very complex. And it can cause glows, arcs, jets, filaments, beads, kinks, bubbles, sausage forms, winds, tornadoes and explosions. The solar wind is an example. It's not just a wind. The use of the word wind is incorrect. It's a plasma electrical current. The important point about all of this is that all of these things can be seen in the laboratory, and we can actually test our ideas in the laboratory, which is something you cannot do with the Big Bang theory. And these things, once you recognise them in the laboratory, you can identify these same things in deep space. And that also is very important. But perhaps the most important thing to recognise is the sheer strength of the electric force compared with gravity. Gravity is such a weak force that, as one professor of physics pointed out to me on the bottom line there, if you divide the gravitational force by the electric force, it's effectively zero. That's why we can jump into the air away from the Earth. The entire Earth cannot stop us from jumping into the air away from it. Or we can use a tiny magnet to lift a ball bearing against the entire pull of the Earth. It's an exceedingly weak force. The electric force is 1,000 trillion times stronger than gravity. And yet this force is ignored in astronomy. You won't find any astronomy textbook that talks about electricity. Nothing in the index. The complexity of plasma behaviour is demonstrated in deep space when you look at planetary nebula. This one here is a little difficult to see because of the light from here, but it's an hourglass shape, and there are concentric hourglasses. And they are glowing. Once again, plasmas can glow. This is the central star here. And there are these little objects here, which none of this is explained by gravitational theory. None of it. But despite the fact that all of these phenomena are very complex in behaviour, they're very simple to explain. The standard electrical engineering and electromagnetic theory can explain all of this, and it can be demonstrated, as I said, in the laboratory. So what physics lies behind the wonderfully mysterious objects that shine in deep space? This is the Cat's Eye Nebula, which is once again a familiar axial shape, but with a helix superimposed on this bubble. It's like a bubble wrap structure. All of these complexities are simply explained in plasma behaviour. But the important point here is that energy has been supplied to the thin gas in space so that some atoms become ionized and glow. It is a glowing plasma. It's just like a fluorescent light or a neon tube. You have to supply electrical energy to get this glow. But what do astronomers say? This is a wind blowing away from the star. It's colliding with gas that's already there. This is all very convenient. And it's also unlike the known behaviour of any hot gas in space. The vacuum of space, it will dissipate immediately. It'll explode to fill the empty space. So having talked a bit about plasma, what is plasma? It's the study of the electrical behaviour of matter on all scales. That's from the atomic up to the galactic and the galactic cluster size. Over here on the left is one of the places where we've learnt a lot about plasma behaviour of very high energies. This device is called a Z-pinch, or an American Z-pinch. What happens is that energy is stored in banks of capacitors around a ring, and then a special switching arrangement feeds all of that electrical energy in a few millionths of a second into a central test object, which is about the size of a baked bean tin. So here you've got, for actually it's billionths of a second, it focuses about 80 times the entire world's output of electricity into a few cubic centimetres. This is the kind of energy density you need to show what's going on in deep space. So the whole thing is based on sound empirical principles, that is observation and experiment. Plasma cosmology accepts a universe of unknown extent and age. This matches what Edwin Hubble felt was the preferred option for his redshift discovery. And it forms the backdrop of the electric universe, because here we have the hard scientific evidence. Plasma cosmology is a recognised study by the IEEE, and I think this is significant. The engineers recognise it, but not the astronomers. It's based on the work of several Nobel Prize winners over the last century, has many successful predictions, but it's ignored by astronomers. One of the pioneers of the electric universe was Christian Berkland, who built a magnetic laboratory in the Arctic Circle under very difficult circumstances. He was a Nobel nominee. A book about his life and work was published a few years ago by Lucy Jago, and I recommend it, called The Northern Lights. As a result of his experiments, he went back to the laboratory and built what he called a terrella, a small earth, inside in a big evacuated glass chamber, and put a magnet in the centre of it, and then performed high energy electrical discharges across that, between that globe and an electrode in the vacuum chamber. And what did he find? He found that he could mimic the auroras. Not only that, he showed he could mimic sunspots, the rings of Saturn, a whole range of astronomical phenomena which are currently thought to have something to do with gravity. The important point, of course, to run this experiment, he had to plug the whole thing into a socket in the wall. It was an electrical theory of auroras and the connection between the sun and the earth. He wrote, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds." He was right. That's plasma cosmology. It's interesting to note that electricity flows through a plasma along the magnetic field direction, which is what an aurora does. These streams come down the magnetic field lines. But the currents take a particular form, which is interesting, and that is this twisted pair or helical arrangement. And this is done because of the nature of the magnetic fields generated by each current and the way they draw together. And this twisting motion is interesting because one of the unsolved problems in cosmology is, where did the rotation of galaxies and planets and stars come from? The answer is here. It's electrical. Alf Vane is the Nobel Prize winner in plasma and is one of the first or the father of plasma cosmology, I would say. And he wrote in the Boston Globe in 1989, people at lower latitudes have not really the opportunity to observe and understand the plasma universe. People are mad to run up to the north in summer to see the dead midnight sun. They should run up in winter to see the live aurora and see the plasma universe. And people who have witnessed the aurora say it's almost a mystical experience and appears to be a living thing in the sky. And this is important when we get a little later on to the mythology. Cosmic power lines. The electrical power transmission lines in space are cosmic Berkland current filaments. They're named after the pioneer Berkland. They're usually in plasma dark mode. In other words, there's not enough plasma density nor current density in most of space for these things to light up and glow, so you cannot see them. But they're there. It's as if you had one of those plasma balls, but you couldn't see the little filaments, but they're there dancing around. Now these Berkland currents are to be found on all scales, from the laboratory, measured in millimetres or centimetres, up to the galactic and supercluster size. So like birds on a power line, we are unaware of the electrical energy coursing past the Earth. As I said before, the solar wind is an electrical current, but it's not regarded as that, of course, for various reasons. But really, we are sitting on an electrified body in an electrified solar system with the sun as the focus of an electric discharge. One of the important aspects of the electric universe model is this, what's called electromagnetic pinch effect. When you have current flowing through a plasma, remember it's a better conductor than copper wire. The magnetic field that's created around the wire, if the current density increases, it gets stronger and stronger and it squeezes the actual plasma itself. This experiment I did in the Telstra labs in Melbourne a few years ago. Now I better explain what's there, and with this light it's a bit difficult to see what's under the table. There's nothing up my sleeve, it's all under the table. Over here there is an insulator and a high voltage terminal which comes up to this wire. Now this is a very thick piece of copper wound around a couple of times and connected to these terminals, or to this terminal here. This terminal here is connected to the other side of the power source, and there's thousands of volts and a very high current will flow when this conducting rod is brought down here. The result is like this. Sorry, I didn't have the sound on, that's a pity. This shows what it does to a conductor. Now remember that plasma is a better conductor than metal, so exactly the same thing happens. If I go back and try it again. That's it. Now the can was very hot. I had to sort of toss it around a bit to cool it down. But you'll notice how it's constricted. That's pinched. Well, the same thing happens to plasma. We won't do it. Now this pinch is extremely significant because one of the unsolved problems of gravitational theory is how do you form galaxies? Because gravitational theory cannot form spiral galaxies, yet they're the most common form of galaxy that we see in the sky. The plasma experiments show that the spiral form is a natural result when two cosmic Berkland currents come close to one another. What happens is they begin to pinch, as you saw in that experiment, and they begin to rotate, as I said. And the result, over a period of 1 billion years, is a progression from this state here, where the two Berkland currents, this is the cross-section marked in yellow, that's the magnetic field, that's what it looks like. A little later, they begin to rotate around one another. Later still, they form this sort of tadpole shape. And later still, you've got the complete spiral galaxy. So this is a natural form of the electric discharge in space. So a spiral galaxy is the grandest visible form of the electric discharge in the universe. It's as simple as that. And it should be as simple as that if we're going to explain all of those beautiful spiral galaxies that we see. It shouldn't require dark matter and black holes and all the other nonsense. The average galactic Berkland current is of the order of 10 million trillion amps. I mean, it's unimaginable, but that's got to power all of the stars in that galaxy. And the radiated synchrotron power, that's both in light and radio, is of the order of 10 trillion watts. I mean, this gives you some idea of how much electricity is involved in the electric universe. This is a computer simulation of what happens in that cosmic Z-pinch, and once again there's sort of fine detail which is very interesting. And as I said before, it's the most efficient way of collecting matter from space and pinching it down and forming a condensed object, either a galaxy or a star. What you have is concentric cylinders of filaments. It forms filaments. It's called the filament instability. And your central current channel, and where the plasma is collected, is in the centre here. The filamentation occurs in the large current. It has the unique property of concentrating matter on axis by a process called Markland convection. And the important thing there is that it sorts the elements. On the outermost regions you have helium and hydrogen, then the other gases, oxygen, nitrogen, then the light elements, carbon, sulfur, followed by the heavy elements, iron, silicon, magnesium, and so on. This is important because that means stars have a central core just like the Earth. Iron, silicon, magnesium, all the heavy elements. And of course an atmosphere largely of hydrogen and helium, which is what we observe. This is quite distinct from the present model, which says it's all hydrogen and helium. Starbirth. An example of the electromagnetic pinch on Earth is bead lightning. This is the sausage instability, if you like. Bead lightning appears after a particularly powerful fork lightning. A series of pinches in the lightning discharge channel has formed a string of glowing plasma beads. What do we see out in deep space? This is October last year, where the Herschel infrared telescope found, hey presto, the stars are being formed in strings. And the quote from the report from the European Space Agency was, a view of an incredible, once it's incredible, network of filamentary structures and features indicating a chain of near simultaneous star formation events glittering like strings of pearls deep in our galaxy. This was a total shock to them, but it was no surprise, of course, to plasma cosmologists. This is we've got 3 e-books out at present available on the web. This is one of them, and a picture which shows this filamentary instability and its relationship to the experiment. The idea with these books is to provide simple books that are easy to read with good diagrams. The interesting things on this particular slide is this over here, where these filaments intersect an ejected ring of gas or dust from a star. It forms these bright beads, and that's exactly what you saw in supernova 1987A. You know, how does an explosion form this beautiful pattern? It doesn't. The star didn't explode, it was an electrical event. The electric universe goes a step further than plasma cosmology. This is a statement from an astronomer. Of course there's electricity in space, but it doesn't do anything. The reason they say that is that they look at that force, the electric force, and they say there's no way you can separate charge because they're held together too strongly. But plasma physicists know that you can do it in a plasma. But of course astronomers are taught a very stunted version of plasma physics. I know, I've done it. And on the left is the giant Faraday disc motor, one of the simplest electrical motors known, at the centre of the Crab Nebula. That's a time-lapse photo of its activity. Gravity and explosions and winds cannot explain that. So we have a whole series of physics misconceptions built into our current cosmology. Physics is really a study of natural philosophy, where you examine the meaning of words, what you really know, and all of that kind of thing. And mathematics is its tool. E equals mc squared signifies that energy, mass and the speed of light are properties of matter. And this is something that natural philosophers might have been able to work out, but the theoretical mathematicians haven't. There can be no vacuum energy. There's no such thing. You must have matter for energy to be present, which brings us to the subject of an ether. There must be a substrate of matter, which is almost intangible, but it has to be there for you to be able to transmit light through space and to have energy travel through space. And quantum effects imply that matter has a resonant substructure. This is something that even Einstein suggested, that quantum theory required a physical model to go with it. As it stands, it's just a recipe book. If that's the case, information can be held in that resonant substructure. And this relates to all kinds of things, homeopathy, for instance, where water molecules can hold information. The original substance doesn't have to be there. The other important thing, and this is where Einstein's theory of relativity falls flat on its face, is that any coherence, in other words, for objects to be able to communicate that information to one another, requires a near infinite speed of transmission of that information. When we send spacecraft into deep space, they have the problem of their motion. They have to tune the receivers on Earth to allow for the Doppler shift. Now, if living creatures had to cater for a Doppler shift, biological systems just wouldn't work, in my opinion. Also, in the planetary system, if the planets did not know where the sun is right at this instant, the system would fall apart in a very short space of time. The planets would be slung out of the solar system. So gravity must operate at near infinite speed, which means in the electric universe model that the electric force itself must also operate at near infinite speed. And these have severe ramifications. So we come to the substructure that I was talking about, and the inspiration for that came from a guy in New York called Ralph Sansbury, who wrote a small paper called Electron Structure. And of course, according to physicists, electrons don't have structure. They're just a little point charge of negative charge. But they must have structure because they've got a magnetic moment. Something must be spinning inside them. With that very simple model, which is a classical model, in other words, you return to real objects, he proposes that all subatomic particles are resonant systems of charged subunits of matter, which he called subtrons, which cannot be created or destroyed. And that's an important principle of physics. It also means that the other stable particles, like the neutrino, must also have a resonant structure. And there was a clue in there as to the nature of the ether. And once again, stability requires the electric force to operate at near infinite speed. The energy, and that is the mass of an object, is stored within the particle, and it's electromagnetic. Mass is a measure of the ease of electrically deforming a particle. I suggest some idea of that might be gained if you have a balloon full of water and you try and move it by pushing it. It would rather deform than actually move. And this is the same for subatomic particles. If you try and accelerate them, they would rather deform than accelerate. And this is what you find in particle accelerators, and it's misinterpreted as an increase in mass of the particle. That's how it appears, but that's not the case. And you can't say that's the case either if you don't understand what mass is in the first place. So this is an attempt to put a simple model forward which explains all of these conundrums. Large particles are obviously easier to deform because the particles are further apart and so appear more massive. That's the case of the proton. The neutrino, which has almost no mass, is the most collapsed and least interactive form of matter. I'll skip through this pretty quickly. In an electric field, an electron is distorted in such a way that it presents a small magnetic dipole. What happens is that the particles rearrange themselves so that the positive charge is on one end and negative on the other, And as a result, in another wire nearby, if the same electric field is operating, the two wires will experience a force between them which is known as the magnetic force, and Ralph Sansbury was able to show that Ampere's law comes straight out of this simple model. That's what we call magnetism. Magnetism is still a puzzle. You know, there's still the idea that you can have magnetic monopoles. Well, this shows you can't. And this is the reason why you can't. It's a dipolar force. Is gravity electrical? I'll put that little cartoon in, it sort of appealed to me. I think I'm the one who's actually regarding the laws of physics more than the physicists with their feet on the ground. The question is of fundamental importance for cosmology and our understanding of the solar system, and the answer should provide insights into the demise of the dinosaurs, into the sky our ancestors saw, and why they feared doomsday. You'd think that's a pretty long bow to draw, but I'll show you that it all comes together quite easily. Electric gravity. What happens in, say, the Earth or the Sun? You have a gravitational field. The nucleus is, if it's just a proton, say a hydrogen atom, the nucleus, the proton, is 2,000 times roughly heavier, more massive than the electron. So what's going to happen in an atom? The nucleus will tend to fall towards the centre of the object, and the electron's orbit will be stretched outwards so that it forms a little electric dipole. Now, this is never considered in any model of the Sun or the Earth. So what you end up with is a dipolar electric field aligned radially. The same thing happens to the subatomic particles within each atom. The electrons, the protons, the neutrons and so on also suffer this distortion. And it is that distortion of the subatomic particles themselves which is the weak force of gravity, and it explains why it's so weak. Those particles are so tiny that the distortion is tinier still. The result is a force which is almost infinitesimally small. So what you end up with is planets and stars are bodies which behave rather like electrets. That is, an object which maintains an electrostatic charge. It also suggests that things inside planets and stars are not exactly what we thought they were. If there are any free electrons around, they'll tend to drift towards the surface, and this would apply particularly to the Sun, where there are plenty of free electrons. And like a subatomic particle under the stress of an electric field, the internal electrical stress modifies the apparent mass and gravity of the planet or star. Now, this is something that's never considered. And so astronomers blithely calculate the mass of a planet by the trajectory of a spacecraft past it, and then calculate the density of that object and say, oh, it must have an iron core, or it's mostly gas or water or whatever. In the case of Saturn, for instance, it's supposed to be able to float in a bath of water if you had one big enough. This is nonsense. What it's telling you is something about the electrical nature of that body. And Saturn, it's showing us something very strange about it. The other interesting thing is that if you exchange charge with a planet, it will change its mass and its gravity and its orbit. So all of those things are involved. We have the problem of Earth's gravity and the giants in the past, and this probably ties in with what Klaus was saying in the last presentation. We have plenty of reports that pterodactyls were too heavy to fly, and in the early days when they first began uncovering dinosaur fossils, they decided they must be waders because they needed buoyancy to support that weight, because it was understood then that an animal that size couldn't exist under present-day gravity without some assistance. That was forgotten, of course, because it was inconvenient, and they found fossils where there was no water. Scaling of muscle and bone strength shows that dinosaurs could not have raised their bodies off the ground in today's gravity, let alone like in the film Jurassic Park, where a brontosaur stands on its hind legs to graze the top of some gigantic tree. For them to move about or fly, it's been calculated that the Earth's gravity needed to be 1/3 or less of today's gravity, and that's a huge change. So global extinction of the dinosaurs required far more than a simple impact. We do not understand gravity, the basis of Big Bang cosmology. That's what that's showing. So changing planetary mass can occur if you have electrical encounters with another body in space. Remember, all planets are charged. All asteroids are charged. All comets are charged. And so the bigger the exchange between two objects, the greater the orbital adjustments. In fact, it forms an efficient mechanism for collision avoidance. And I suggest this would be the case with a comet approaching the Earth. Also, it helps explain the spacing of the planetary orbits. The inner planet reduces its charge or polarization, or in other words, its mass, and the outer planet increases its polarization in the exchange. So the question is this possible? One of the things that's never really advertised is that gravity for more than two bodies in orbit is an unstable system. In other words, if one of the planets was to move slightly out of its orbit, there's nothing to restore it to its previous orbit. In fact, the chances are it will destabilise the next planet and so on, and you'll end up with utter chaos. And this is what the mathematics shows as well. But people ignore the mathematics when it doesn't show what they want. So, can this charge transfer occur? Yes, it can. There is an intermittent circuit for transferring electrons from the inner planet to the outer when they are aligned with the Sun, and this was discovered back in the 80s by a spacecraft between the SOHO spacecraft, which was orbiting between the Earth and the Sun, and it found when Venus was lined up with the Sun, it detected all of these stringy things. Now, stringy things are another word for Berkland currents, Berkland filaments. So this is the time when charge transfer can occur between planets. It's in the correct sense to induce the planets to move apart into orbits having electrical least interaction. This explains why the system is stable. Gravity can't do it, this model can. Quickly, it will appear as though the system operates according to Newton's law, with no sign of recent instability. So we could have had a complete chaos in the solar system of 10,000, 20,000 years ago, and there'd be no sign of it today. Just quickly, nuclear physics, matter cannot be created or destroyed, once again. So what happens in an atom bomb? The complicated zoo of particles created in atom smashes and atom bombs are short-lived resonance states of those subtrons. Antimatter is a misnomer. This is one of the confusing aspects of present physics. There's no such thing as antimatter. If all matter is made up of subtrons, it just means that antimatter is a rearrangement of those subtrons so that it has the opposite charge to its normal particle. It means that you cannot annihilate. The word annihilate in atomic physics should never be used. It also means that cold fusion and biological transmutation of elements, according to the French professor Louie is possible. And it's possible in the presence of a resonant catalyst like a heavy metal atom. Those heavy metal atoms, like iron and magnesium and so on, have so many resonances built into them that if you brought another particle close to them, they can actually pick up that resonance and be used to transmute elements. And it's interesting to note that hemoglobin uses the iron atom and chlorophyll uses the magnesium atom to perform minor miracles. Space and time. They're two different concepts. Space can only be three-dimensional and is unaffected by the presence of matter. And due to the near infinite speed on our scale of the electric force, there is a universal time, a universal clock. Goodbye, Einstein. And also, for those Doctor Who fans, I'm afraid time travel is impossible. Still good fun. So we need a return to the ether. Einstein discarded the ether without explaining how Maxwell's laws of electromagnetic radiation could still work, because Maxwell's laws require a medium, an ether. Empty space is full of neutrinos, and I suggest that is the medium. You can evacuate a chamber so there's not an atom in it, if that were possible, but it would still be teeming with neutrinos. Because they've got a vanishingly small mass, they're the lowest energy state of matter. Composed of subtrons, they will also distort in an electric field, and therefore they will transmit energy through what is supposed to be a complete vacuum. The speed of light is related to the difficulty of spinning a neutrino. So in other words, the speed of light is a property of matter. Nothing to do with space. Neutrinos may reintroduce cause and effect to radioactive decay. That's just an added bonus. So James Clerk Maxwell was right. Light is an electric ripple moving through a medium, and the speed of light depends on the inertia of the medium to the electric field. Light is not a particle, there's no such thing as a photon, and quantum effects are due to resonance between the transmitter and receiver via that electric force. When you think about it, light is exceedingly slow. It takes 8 minutes to get from the sun to the earth, and it takes 100,000 years to get from one side of a galaxy to another. It's absolutely hopeless as a means of transferring information to allow these objects to exist as a coherent structure. So light travels like ripples on a pond. On the other hand, gravity travels swiftly, straight through, like the speed of sound in water. It's just an analogy, but it gives you some idea of what's going on. Said that before. Otherwise, the universe would be completely incoherent. Quantum effects, they're due to the near infinite speed interaction between particles. Such instant behaviour is considered presently as spooky. It's not, it's natural. It's the electric force. And the disconnect between cause and effect in present-day quantum theory allows infinite possibilities and a descent into science fiction. If anyone's seen that film, What the Bleep, you'll know what I'm talking about. So some of our heroes will have to be taken down from their pedestals and taken to the museum. Science did take a wrong turn in the 1920s and 30s. Perception became reality. Einstein's view that it was like saying a train receding into the distance. The person waving to you is actually shrinking. Their watch is ticking more slowly. It's rubbish. I mean, we know it's rubbish, but unfortunately that kind of perception is what has been introduced into physics. Once again, E equals mc squared. And as one physicist pointed out, everyone who takes relativity seriously believes in the reality of at least one direction in which one cannot point. In other words, there are only 3 dimensions of space. You point me the 4th one. So those who followed Einstein bequeathed us a disconnected, incoherent universe that simply cannot function or give rise to life. I don't include Einstein in there because he had the integrity to say that probably most of what he'd written was wrong. It's those who followed him who perpetuated and built the myth. The electric universe. This is a quote from early on when I was writing this stuff. From the smallest particle to the largest galactic formations, a web of circuitry and the electric force connects and unifies all of nature, organising galaxies, energising stars, giving birth to planets, and on our own world, controlling weather and animating biological organisms. There are no isolated islands in space, which is quite distinct from the hopeless Big Bang cosmology where everything's disconnected and accidental. The electric sun. Arthur Eddington bequeathed us a simple model for such a simple thing as a star. But at that stage, plasma physics was in its infancy. So I suppose he could be forgiven. He used simple gas laws applicable on Earth. As I said, plasma is something we don't experience on Earth because we only experience normally solids, liquids and gases. Lightning is a plasma, but we don't experience that unless we're very unlucky. It resulted in a simplistic model that took no account of the observed complexities of the sun. All of the things that happen on the surface of the sun have no explanation in the standard model. They have to be, add-ons, add-on explanations. That's sunspots, granulation, the umbras of sunspots, spicules, coronal mass ejections. All of these things have no business in that standard model. The sun's surface is carpeted with complex magnetic fields. Only electricity can produce magnetic fields. Therefore, the sun must be understood in terms of electric circuits. And this is something that Hans Alfvén, the Nobel Prize winner, was saying for decades. He actually drew the circuits. Where are these circuits? Well, Alfvén showed us. What creates them? That's the motion of plasma in the universe. And what sustains them? Well, when you get to that kind of question, you're asking the big questions. And the answer is we don't know. This guy was a doctor of physics. He's a fellow of the Institute of Electrical Engineers, the Institute of Physics and the Royal Astronomical Society, so he covered the ground pretty well. He was also an expert on lightning effects. In 1941, he identified cosmic jets, solar flares, magnetic fields and high temperatures as electric discharge phenomena on the sun and in deep space. He published an all-electric universe in Electrical Review in 1960. So there are precursors. The build-up to the electric universe has been about a century. This guy inspired me in 1972 when he wrote articles on the gas discharge solar model. The beauty of it is, as he pointed out, the modern astrophysical concept that ascribes the sun's energy to thermonuclear reactions deep in the solar interior is contradicted by nearly every observable aspect of the sun. And until that's pointed out, you just sort of go along with the story. The reason why nuclear energy was applied, of course, was that Eddington had the problem of how do you sustain the energy of the sun over billions of years. And of course, when thermonuclear energy popped up, he grabbed it immediately because that was about the only answer that was available to him. But if the galaxy is supplying the power, that problem goes away. The sun is not burning itself up. It's actually using power that it gathers from the galaxy. So he provided a simple gas discharge model which is applicable to all stars. It explains red giants, white dwarfs, and all of the other various forms of stars we observe, and the planetary nebulae. I won't go into detail here, but it shows a very interesting point. The photosphere is made up of these granules, but the granules themselves are actually tufts on the top of what you might call electrical tornadoes. And the electrical characteristics of these is that of a transistor. Because one of the puzzles is, why does the sun's output stay so steady when we know that the sunspot cycle is related to X-rays, and X-rays are related to the electrical input, and the sun is a variable star in X-rays. It goes dark at the low point in the cycle, and it's quite bright in X-rays at the high point. So the sun is a variable star in X-rays. Why does it shine so steadily? The answer is simple electrical engineering. These tufts act to steady the light output of a star. It's just brilliant. What actually happens is that acts like a barrier, like a hill. So the charged particles trying to escape from the sun find this barrier, and this barrier changes, it shifts it in order to maintain steady output. When they get the other side, they rush down the hill, collide with incoming matter and form the high energy corona, the 20 million degrees, 2 million degree corona, which is a total puzzle to the standard model. So we have transistor-like power control for the sun. I mean, it's just amazing. Sunspots are not explained by the standard model. They're an embarrassment. Their darkness, structure and behaviour, the shift in latitude and so on, have defied all attempts to explain them. It doesn't look like turbulent, boiling hot gases, which is what we're told. Those things are structured. And why is the sunspot dark if the sun is hotter underneath? It should be brighter. They give us a story about magnetic constriction, stopping the flow of heat. But that's a desperate story. The simplest answer is that it's cooler, because the interior of the sun is not producing the heat energy that we receive. This is a picture from our e-book on the electric sun, which shows here that the centre of the sun is a solid or a liquid. It has an extensive atmosphere, thousands of degrees cooler than the photosphere, which is this yellow line here. Above that is the chromosphere, which is that red glow you see during a total eclipse. And then the corona, 1 million degrees or 2 million degrees out here, rising to 20 million further out. There's no way you can have a 16 million degree core, 20 million degree corona and a 5,000 degree photosphere in the middle. Absolute nonsense. The superheated corona is a familiar glow discharge phenomenon recognised by high voltage engineers.